We're going to start today by looking at the average rate of change, and then take that and apply it to how to write the equation of a secant line. So average rate of change is going to be directly related to slope. However, slope deals specifically with the rate of change of a line, where we want to do the average rate of change of a function that maybe is not a perfectly straight line. So if we think about f of x equals x squared, and we put this on a graph, just a rough sketch, it's going to look like this. This function does not have a constant rate of change. The rate of change here, our slope would be negative. It's moving down, it's decreasing. At this point, we have a slope of 0 as it changes direction, and then the slope's going to go back up. It's actually going to get steeper too. So not only is it increasing here, it starts to increase faster and faster and faster and get steeper and steeper. So our rate of change for this parabola, it does vary. When we talk about average rate of change, we're talking about the rate of change between 2 points. So if you pick 2 points on this function, the average rate of change is the slope between those 2 points. So if we look at just this interval from here to here, maybe this is like 2 to 4, we're looking at the rate of change. How much does the y go up compared to how far over we go? So we're looking at the slope of this line to these points. Notice if I were to pick 2 different points, so maybe instead of those 2, I pick those 2 points. Now the average rate of change of those is going to be different. So now I've got a line with maybe a smaller slope. Or even if I pick lines over here, the line that goes through those 2, the secant line, is now going to have a negative slope. So depending on the points you pick from the function, directly determines the average rate of change over that interval. And for a function, some could be positive, some could be negative. Okay, we could even, if we picked like a point here and then maybe one over there, we could even get an average rate of change of 0. It would zero out. So although it goes down and back up, over that interval, it doesn't actually change. Okay, it has average rate of change of 0. So this is going to be directly related to, in Algebra 1, when we did y2 minus y1 over x2 minus x1. This is the change in function value. So although in Algebra 1 we used y instead of f of x, it's the change in your outputs, it's change in your y values. Down here, this is our change in x. Change or difference, okay, in our x. We're going to write this today as f of a minus f of b over, so it's the function at our first point, the function at our second point, over a minus b, to find the slope of that line. If you had trig in the fall, we did this in trig, so I'm not sure if trig in summer school does or not, but trig in the fall, we did do this a little bit. So let's do an example. I've got a function that's 2x squared plus 2, and I want to find the average rate of change on the interval 0 to 1/3. So I want to figure out how much the function increases when x goes from 0 to 1/3. So the first thing we need to do, if we're looking here, we know our values, our a is 0 and our b is 1/3. But we need to figure out f of a and f of b. So those are our x values. That's the difference in the x's. We need to figure out what the difference in the y values is for those 2 points. So I'm going to find f of 0. And if I simplify that, f of 0 is 2. Then I'm going to find f of 1/3. Let's see, f of 1/3, 1/3 squared, it's going to be 1/9. So we've got 2/9 plus 2, so we got 2 and 2/9, or, what is that, 29ths? Okay, if you want it as an improper fraction. We're going to take these values and plug them in. If you want to use this value, that's fine. So this and this. We're going to plug those into our slope formula. So we're going to do our f of a minus f of b over a minus b. So f of a was 2. F of b is 2 2/9. A was 0, and b was 1/3. So 2 minus 2 2/9 is a negative 2/9. This would be a negative 1/3. They're both negative, so that'll be positive. We simplify that. We get 6 over 9, which is 2/3. This is the average rate of change, or you could think about it as the slope. Between 0 and 1/3 for that function. So if you look at what the function looks like, it's going to be a parabola. So we've got 2x squared plus 2. There it is. If we were to maybe zoom in a little bit. So we're saying that between our x values of 0 and 1/3, so right in here, the average rate of change is 2/3. It has a positive slope. It's going up. So it's like 1/3 would be about right there. Okay, we've got a positive rate of change on that side of our parabola of 2/3, of 2 over 3. Now, another question that this could ask is it could ask you to write the equation of the secant line that goes through those points. Now, a secant line is a line that intersects twice. That's a vocabulary word from geometry. So a secant line is a line that intersects, in geometry it would have been a circle, but it intersects, in this case, our function at 2 points. So it's going to intersect at the point 0, 2, and the point 1/3 and 2/9. So we've got 2 points, and we have the slope. So we're going to go back in time to Algebra 1, and we're going to write the equation of the secant line using y equals mx plus b. You can pick either of your points, but the smarter point to pick is the point 0, 2, because the other one's got two fractions, so why pick that one? And we have our slope of 2/3. So I'm going to plug all this in to find my b value. So y is 2, m is 2/3, x is 0, that becomes 0, and so b is 2. So the secant line would be y equals 2/3 x plus 2. That's the equation of the line that goes through both of these points on that parabola. Has a slope of 2/3 because that's the average rate of change on that interval. And then we found the y-intercept by plugging in. Now, this was the y-intercept, okay? But in some cases, your interval won't include 0. It might include other points, in which case this is the process you use to find that. All right, thanks for watching. I hope this helped those of you that are gone today, and have a great rest of your day.